minus the small r square is 161. 161 square. Okay, so this will be pi into a square minus b square. It will be 164.5 plus 161 in one bracket, in under bracket. It will be 164.5 minus 161. The difference is 3.5. The sum is, let me find out that sum. This area, let me now calculate area. Therefore, this area is equal to pi is 22.7 into sum of these two. This is 1 plus 4, 5.5 is there. 1 plus 4, 5, and 6 plus 6, 12, 2, 1 carry. 1 plus 1, 2, and 1, 3, 325.5 into 3.5, because the difference is of 3.5 there. Okay, so this is by 7, it can be cancelled out. 0.5, 0.575 to 35, but it is 3.5, so it is 0.5. Now let us multiply this by. Therefore, this is the area we have to calculate. Area also we have to calculate. This is 22 into these two multiplications. This is 3255. Let me divide it into 5 divided by 100. Why 100? For this point 0.5, 5 upon 10, and this 325.5, so 0.5. Again 10 we have taken in the denominator, so this is 100 in the denominator. So let us cancel out this by 5, 5. So this is 5 20 times 5 to 10 0. Again by 5. This is 5 4 and this is 5 6 is 32, 25, 5 5 is 25, and 5 1 5, 6 51. Again 4, this is 2, and this is 11 times. Now only 2 is there. In the denominator 2 is left. Okay, this let me multiply. 11 into 1 is 11. 1 carry. 11 5 is 55 and 1 56. 6 5 carry. 11 6 is 66. 66 and 5. 66 and 5 71. 66 and 5 is 71. So 17161 divided by 2 is square meter. Square meters. Now divide it by 2. We will get 2 3 are 6. 1 carry 10, 11, it is 2 5 10, 1 carry 16, 2 8 16, again 0.5, because here it was 16 complete, 1 was left, so that means 0 times 0.5, 10 is there. Okay, this is 3580.5 square meters. This is area of the road. Try to understand. This area of the road, which is a smaller one, this area of the ring. Area of this road is calculated, but the cost of this grabbing it. The second answer is area of the road is equal to 3580.5 square meters. This is the second answer. Third answer, cost of graveling. Now let us calculate what is cost of graveling. Third point was cost of graveling. Now cost of graveling the cost of graveling the road is equal to area of the road into the rate of graveling. What is the rate of graveling? 30 paisa per square meter. 30 paisa. Okay. This is equal to area is what? 3580.5 into 30 paisa means 30 upon 100 rupees. Now this is in rupees. So this 1 0 cancelled out. 10 will come here, 0.05 into 3. So let me again multiply. This is rupees. 358.05 into 3. So this point is come here. Okay, so this decimal has one more point has shifted to left hand side. This 358.05 into 3. Total rupees will be 3 5 15. 0.3 at 24 2 carry. 3 5 15 and 2 17. 7 1 carry. 3 3 9 and 1 10. 1074.15 rupees. So rupees 1074.15 15 paisa and 1074 rupees 15 paisa. This is the third answer. Okay, so rupees cost is this much rupees, 1074 rupees and 15 paisa. Okay, so this is the value of the cost of graveling this path, this road, graveling the road. So these are three answers of this question completed. So this is a process of just solving the question. Please just try to understand the basics of this point. How we calculate the area of the road, that is the area of the ring. Outer radius and inner radius take, and then find the areas difference of them. That is the area. Now this is question number 13 we have completed. Yeah. Question number 14, what is that? There is an equilateral triangle of which, okay, this is 14th question. Before that, let me clean this. Let me clean this whole. Now question number 14. Try to understand that what is the kind of question 14. Now question number 14. Question number 14 is what kind? Now it says that there is an equilateral triangle. Equilateral triangle. This is an equilateral triangle. Okay. A, B, C, let me take. Then equilateral triangle. All three sides are equal. Each angle is 60 degrees. Okay. There is an equilateral triangle of which each side is 2 meters. This is 2 meter side. 2 meter side. Okay. Of which each side is 2 meters. With all the three corners. With all the three corners as centers. Circles are described, each of radius 1 meter. Each of radius 1 meter. This is 2 meter. It means this will pass through like this. Circle. Each circle will touch the other one. Okay, so each circle will touch the other one. These three circles are touching each other. I'm sorry, this is the smaller I have drawn, but this is the bigger one. Let me take it like this. Okay, now what the point required? So what is the area? We have to find out what center to start each of the radius 1 meter, 1 meter radius. Radius this A. Let me take this touching point is A, B, C. We have taken D point. This is E point, and this is F point. So AD here is equal to 1 meter. So this is the radius of the circle. Each circle is having AD is equal to, this is BD or BF, whatever, equal to CE. So radius of each circle is the same 1 meter. Right. Each corner we have drawn a circle with radius 1 meter. Okay, so that then what we have to find out? With all the three corners as center, circles are described, each of radius 1 meter. Now first point is calculate the area common to all the circles. Okay, so area we have to find out of all the circles and the triangle. Area of the, okay, calculate the area common to all the circles and the triangle. So common to all the circles, and this is the common area. What will we find out? Area of these three sectors, 60 degree each angle, 60 degree each angle. What the area of each sector? So Now these areas are making 60 degree, 60 degree, 60 degree. What the three sectors areas minus, area of the triangle minus area of these three sectors. We can say that these three sectors are having 60 degree, 60 degree, 60 degree. So this is semicircle area of one semicircle. Radius is 1, so we can find out area of what is semicircle of area. That is subtract from area of the triangle. That can also be calculated. Or we can find the area of one sector into 3, area of all the 3 sectors. This is sectoral area. So subtract this area from the triangle area. That is common area. Common to both triangle and there is a common area. We have to calculate. This is A part. Calculate the common area common to all the circles and the triangle. Now find the area of the remaining portion of the triangle. Okay. What is the remaining portion of the triangle? The remaining portion of the triangle. This is the common to. So the two things are required. What is the two things required? So area of all the 3 sectors. Then we have to find out first thing, and area common to. Also first question was calculate the area common to all the circles. Common to all the circles. So common to all the circles is this area, which is same area. That is common area we have to calculate. This is area, this area, this area. All these 3 areas are equal to each other. That is common area to all the circles. That area we have to calculate. Okay, so that is area of the sector. Calculate the area common to all the circles and the triangle. So triangle common to all the sector. So the 3 areas we have to calculate. Okay, that I got the point. Areas to common to all the 3 circles, all the 3 circles and common to this. So that means area of these 3 sectors we have to calculate. That is also lying in the triangle. Then it says, what is the second point is to find the area of the remaining portion of the triangle. This is the remaining portion of the triangle. This area is the second part here. Okay, that I got. What is given to us now? Question is asked here. What is given us are an equilateral triangle. An equilateral triangle ABC in which side is of 2 meters. Secondly, taking 3 vertices of the triangle as centers. Circles are drawn. Circles are drawn of radius 1 meter. Circles are drawn of radius 1 meter. Okay, taking A, B, C, the 3 vertices as centers, these circles are drawn. To find here, second thing, radius of the circle is 1 meter. To find the first part, area common to all the 3 circles and the triangle. This is first point. Area common to all the 3 circles. That means this area plus this area only, and this is also common in triangle. Common to triangle also. This is lying in the triangle also. There is common area. Calculate the area common to all the circles and the triangle. Okay. And the second point is find the area of the remaining portion of the triangle. The remaining portion is this. This remaining portion, this one. That area also there. Second part is find the area of the remaining portion of the triangle. Remaining portion. Find area of the remaining portion of the triangle. ABC. Let me take ABC here, triangle. The 2 points required here. What is area of one sector? Solution now. Let me find the solution here. Area of the 3 sectors. The 3 sectors which are equal in areas, which are equal in areas, Okay, that means what is that area? Why they are equal in areas? Because each is having same radius and same angle. Okay, and so what is area of one sector? Now area of a sector, okay, is equal to theta upon 360 into pi r square, area of the circle. Here theta is 60 degree upon 360 into pi 22 upon 7 into radius is 1 square. This is 6, 1 upon 6 here, because 60 upon 360 means 1.6 into 3 out of the area. We have to calculate. Let me remove this. Therefore, area solution we are calculating. The solution. Therefore, area of the 3 sectors. The 3 sectors is equal to 3 into area of one sector. Area of one sector. Look, why? Because they are equal in areas. So you find area of one sector and multiply it by 3. This is 3 into what is area of one sector? You have calculated this as 1.6 into pi, that means 22.7. This is pi here. R square is 1 because radius is 1. Okay, so that is the value here. 3 to the 6 to 11 times 11 upon 7. This is square meter. Now this is area of the 3 common sectors. This is common to both triangle and the 3 circles here. So common to 3 circles is the same angle, same value, same. So 3 sectors area, which is common to triangle as well as, let me take the duster. So this is area 11 by 7 square meters, because this is in meters. Okay, now what is the area of the triangle? Now, second part we have to find out, secondary or B part of it. Area of the triangle. Now, area of the equilateral triangle. Area of the equilateral triangle ABC is equal to, you know, this under root 3 by 4 into side square. Into side square. It's a root 3 upon 4 into 2 square. Side square is 2 square. This is how much? 4. Alright, so this is 4 cancelled out. So root 3 square meter. Root 3 square meter. 1.732 is value is. So what is the common area, leftover area? Therefore, the remaining area. Answer solution we have calculated. Second answer is common area or remaining area. Therefore, remaining area of the triangle ABC is equal to area of the triangle ABC minus area of 3 sectors. Area of 3 sectors. So this is equal to root 3. We have calculated root 3 square meter minus 11 upon 7 square meter. This is what? Let me just calculate this. So root 3 value is 1.732 minus 11 upon 7 will be 11, 7 1 is 7. Remaining value is 11 minus 7 is 4. Alright. That means 40. 11 5 ja 7 5 ja 35. Again 5 7 7 7 ja 40 9. Again 1 10 7 1 ja 7. Only up to 3 digits. Let me calculate. So this will be how much? 2 minus 1 is 1. 13 minus 7 is 5. No, 6. 13 minus 7 is 6. Okay, then 1 carry is 6. 7 minus 6 is 1. Point. 0.1 is square meter. If I have to multiply this by centimeters, so 100 into 100, that is square centimeter, which is equal to 0.161 into 100 into 100, because 1 is square meter. 1 meter is 100, 100 into 100 is square centimeter. If I calculate this in centimeters, then this will be 3 decimals, so only 1610. But 4 zeros multiplied to this 3 decimals, point is after 3 decimals, 3 numbers, decimal point is there, so 3 decimals, 3 zeros are removed and 1 zero is there. So 1610 is square centimeter. This is common area, the remaining area in the triangle out of these 3 sectors area. Subtract area of the 3 sectors from the area of the triangle. This is the common remaining area, 1610 square meter, square centimeter. This is in centimeters, square centimeters. Okay, so this is the area. 103 square meter was area of the triangle, and 11 by 7 was area of the 3 sectors. It was the area of the 3 sectors. Okay, so 11 by 7 was first answer, and then root 3 square meter is the area of the triangle, equilateral triangle. Then subtract this. So this is the answer here. So the two parts are completed. This is question number 14. Let us take question number 15 here. What does question number 15 say? Now question number 15 says the diameter of a coin is 1 centimeter of a coin. If 4 of these coins be placed on a table, so that the rim at each touch that of the other two, and the area of unoccupied space between them. Okay, these are 3 coins here. 3 coins here. Okay, and the 3 coins here. Now these 3 coins, again the 3 triangles are there. So if I join the centers, the same type of triangle is formed. The 3 centers coins are of same size. 1 centimeter is the diameter. So 0.5 centimeter is the radius. 1.2 is 0.5. So radius is, this is 0.5 centimeter. O, let me take, this is ABC we have taken, so this is point. Let me take again ABCD. This is E point and this is F point. Okay, so this area which is common to lying in between these 3 coins, find the area of unoccupied space between them. So this area, again, what is the area of the equilateral triangle? So area of the equilateral triangle is, now because this distance will be 0.5 plus 0.5, so radius or size of the equilateral triangle is 1 centimeter. 1 centimeter. Okay, so that means area of the triangle we have to calculate. And again, equilateral triangle, this is again sector of 60 degree each, because equilateral triangle is formed. What is given to us? 3 coins of diameter of 1 centimeter each, of diameter 1 centimeter each. They are kept, or they are kept on a table, touching each other externally, or rim wise. This is rim, touching each other externally, touching each other externally. All right. So to find again area, the area of the space, unoccupied by them. Unoccupied. What do you mean by this? This is area which is not occupied by them. In between them. Table, because table size is not given. The diameter of a coin is this much. If four of these, I'm sorry, this is not 3 but 4 of them. Sorry friend, I have taken this wrongly. The diameter of a coin is 1 centimeter. If 4 of these coins be placed on a table, okay, then the rim of each touches the, I'm sorry, this is not of this kind. The figure is 4 coins are touching each other. 4 coins are touching each other. These are 4 coins here. Okay, so if I just join them, tangent lines. Okay, so what is this distance? Total distance here. Simple. So what is area of the, this is 1 centimeter diameter, 1 centimeter, so 2 centimeter is the side of the square, 2 centimeter again. Simple. Now what is the area of the square? Area of the square minus area of these coins. These are the circular coins. So area of 4 coins minus area of the square minus area of the 4 coins. Simple. Unoccupied area is this. That can be easily calculated now. So sorry. So what is given to us? 3 coins, not 3 coins but 4 coins. We are given here 4 coins of diameter 1 centimeter each. They are kept on a table touching each other externally like this. To find the area of the space unoccupied by them on the table. This is the table. Okay, so table is not given to us, but size of the table is known. This is square type of table. The diameter, rim of each other touches each of the other table on a table. Show that, okay, find between them. So what is the area between them? To find area of the space unoccupied by them on the table. Simple. A solution. So area of the table unoccupied by the coins, is equal to area of the table minus areas of the 4 coins. Simple. Area of the 4 coins. This is area of the square is side square minus 4 into area of 1 coin. Area of 1 coin. That means side square is 2 square, 2 centimeter square. What is radius of this? 0.5. That means pi r square. This is 4 into pi into r square. R square means 0.5 square. Pi r square. Okay. So 2 square means, let me take first pi r square. That will be proper thing. This is pi into r square. But r is here 0.5. Radius of the diameter is 1 centimeter. The radius of each coin is, so this is 4 minus 4 pi into r is 0.5 whole square. Okay guys, so let me now stop it here. The remaining questions I'll take after 5 minutes time, because now camera is full. Okay guys, so see you after 5 minutes time. This is the formula answer. Okay, let's check if after 5 minutes time.